This instructional video is designed to show you how to use the method of initial rates to determine the form of the rate law when you're given initial concentrations of your reactants and the initial rate of reaction. So the generalized rate law says that the rate is equal to some rate constant multiplying factors representing your individual concentrations. The order of each component is its exponent, and we'll use a generic m because we don't know yet, and a generic p because we also don't know that one's order. Now, in order to determine this, we have to compare our experimental data. And so we'll be comparing trial number 1 with trial number 3. And then we'll go back and compare trial number 1 with trial number 2. Now, the comparison of 1 versus 3 shows us that the hydrogen concentration remains the same. And so the only things that change is the concentration of our calcium hydroxide and the rate. So that comparison will give us the order for calcium hydroxide. In the same way, if we look at 1 versus 2, we see that the rate changes, and the only thing that changes is the concentration of our hydrogen, so that will give us its reaction order. So once you've determined what it is you're going to use to do these comparisons, the next step is to actually do the comparison. And I like to start by looking at the rate. So if we're doing the 1 versus 3 comparison, we want to try to determine the relationship between the rate for 1 and the rate for trial 3. They're not equal to each other, and in fact we see that if we multiply rate 1 by 3, then we have an equality. The reason we want to do it this way is that I know what I need to plug in for rate 1. I need the concentrations of calcium hydroxide and hydrogen for that. And for rate 3, I'll need those specific concentrations. And so I can erase out and expand this by substitution, saying 3 times, and the rate is the rate constant, times concentration of calcium raised to the m, concentration of hydrogen raised to the p. So that's 3 times whatever I have for rate number 1. Grab my eraser and fill in what I have for rate 3. The rate for the third one is still that same constant, but now I have 0.6 raised to the m for my calcium hydroxide, and I still have 0.1 raised to the p. And so now it's straightforward to observe what things are going to cancel here. I have the rate constant and the rate constant, so those will cancel. The other thing I have is 0.1 raised to the p to cancel with this 0.1 raised to the p. And so now I want to get all of my numbers on one side and everything with my variables on the other. So I'm going to divide both sides by 0.2 raised to the m. That effectively cancels here, leaving me with 3 equals 0.6 over 0.2, all raised to the m power. Well, 0.6 over 0.2 is just equal to 3, so I have 3 equals 3 raised to something, which means that m is going to equal 1. And so I've now determined the rate order for the calcium hydroxide is equal to 1. We'll go through the same steps to determine the order for hydrogen. I'm comparing 1 versus 2. So I start by determining the relationship between rate 1 and rate 2. And looking at these values, 5 here and 20 here, I can see that I need to multiply this by 4 to have both things equal. So I can substitute in for rate 2. It's going to be the rate constant. The calcium hydroxide concentration is 0.2. I know that's raised to the 1 now. Hydrogen is 0.2, and that's raised to the p. And now I need to do 4 times rate 1, so 4 times rate constant. And for rate 1, I have 0.2 for my calcium hydroxide, and I have 0.1 raised to the p for my hydrogen. So we're going to do the same thing with our cancellations now. I see that I have rate constant times 0.2 to the 1 on both sides, and I can cancel both of them. I need to simplify, so I will divide both sides by 0.1 raised to the p. And now that that cancels, I'm left with 4 equals 0.2 over 0.1. This is all raised to the p power. Well, 0.2 over 0.1 is just equal to 2. So I have 4 equals 2 raised to something. That something should be 2. And so now I know the order for hydrogen. So we've done all of this so that I can now write out the full form of the rate law. And we have that the initial reaction rate will be equal to the rate constant times the concentration of calcium hydroxide raised to the 1 and concentration of hydrogen squared. This means that this reaction is first order in calcium hydroxide, second order in hydrogen, and third order overall.